Right, let's get cracking. That did not work. Yeah, there we go. Okay, there we go. Oh, a little bit of waffle about me. I've been here before, so I'm going to skip through most of this. I've worked for an awful lot of places over the years. I've worked some government jobs, some manufacturing jobs, and briefly I was one of them slightly scary, dodgy contractors that your mum always warned you about. But these days, I have just recently taken up a job with Müller Yogurt. And in answer to the usual question, yes, I do believe you get free yogurt. I haven't had any yet because I'm working from home, but there we go. So, yeah, I've been in the business for about 15 years. My contact details are all in the top right there if anyone is interested for some reason in talking to me. But I'll probably come back to this at the end. So, this, I believe, is the great conflict of our age. Two men, because let's face it, Michael J. Fox is fooling no one, and diametric opposites. The one is straight-laced and boring and hard-working. The other is the slacker who takes it easy. But of these two men, which one got to ride around in a flying car, time travel to the future, get to be a cowboy, accidentally nearly sleep with his own mum? Maybe, possibly, we won't dwell on that last one. But my point is that of these two, which one is the most fun? And it's the guy that takes it easy. So this talk broadly is going to be about ways to take it easy as a developer to accomplish an awful lot more work with a lot less effort. So broadly speaking, these are the components of a project. And of these, which ones can we, as developers, find ways to make the most impact in terms of reducing overall effort? Well, gathering requirements, designing solutions, that's typically your BAs, your architects. Testing will be, probably your testers if you're fortunate. And coding enhancements is where we, as developers, do our work. And of these, by an awfully long way, enhancements is where projects spend the vast majority of our time. Someone's just asking, by the way, if the video will be available afterwards. Dan, I don't know whether you can step in. I believe it will be, won't it? We're on YouTube.
Yes, it will be. Yeah.
Okie dokie. Rest assured. Also, before I get asked, I will put the slides up later for anyone that wants to see them. I usually stick a link up on Twitter or whatever. Right. Okay. Enhancements. Yes, because at this point I normally like to see shows of hands, but I'm just going to have to pretend that people are doing so. But I'd normally say, like, who's got a project that's more than 5 years old, and I usually get a lot of hands. And then I'll say 10 years old and still quite a lot of hands. And I've usually gone as far as 15, 20, and you'll still usually see a hand or so up. I've known of applications older than 25 years. It happens. Oh, Suman Kumar says 15. Yeah, pretty typical stuff. So, but this is the point. The point is that by orders of magnitude, projects spend most of their time being enhanced by having little bits changed and added to. The initial development effort is a teeny tiny piece of the application's life. So a little bit of extra effort spent during that initial dev can save you hours upon hours of time later. And what are the problems that tend to occur when you're trying to maintain your code base? Well, unclear requirements, down to your BAs probably. Project management issues, well, that is between yourself and whichever PM you believe in. But the legacy code base, that's down to us as developers to do something with. And what causes problems with the legacy code base? Working out what in heck it actually does quite often. You've got the problem of, what does this code do? How does it do it? How do I make my changes? I have worked in places where, no joke, a requirement has come in that sounds simple, and then I've had to spend days staring at highly complex code just to work out what it does, and then a day or so thinking hard to determine how and what change I should make, and then popping in, say, 1 or 2 extra lines of code and jobs are good. And it looks, yeah, Dan says he's been there. I'm sure most of us have. I could name names, but I won't. But And the problem is that it's not that I was wasting time. I was working hard all of those days in order to produce that little line of code. And that is a complete waste of everybody's time. And it looks awful when I try to explain it to my boss. So what are the components of a function? Broadly speaking, it's these guys. So parameters and return value, that's the stuff going in, the stuff going out. And in the middle, we've kind of got these two concepts. We've got the code structure and the business logic. So the business logic, of course, is the what this thing does. That is what this function is intended to do. If someone non-technical wandered by and asked what that did, the business logic is what you would say to them. That is that. The code structure is the how of doing it. It's how we accomplish the business logic. It's the nested if statements, the for loops, the whiles, the slightly bananas algorithms, whatever. But the point is that this is the bits and pieces of code Lego that we're sticking together in order to accomplish the building of our rather lovely castle with the knights and stuff that we make out of our Lego bricks. And that's those two bits. So there is a concept in audio engineering of a signal to noise ratio. The signal is the thing you're actually trying to listen to. But along with the signal comes the unpleasant noise, the extra stuff that's along for the ride in the playback, which may be hard or impossible to remove. The signal to noise ratio indicates the fidelity of the ratio between the thing you're listening to the thing you're not. The noise is the hiss on a cassette, it's the rumble on a record, it's on a Justin Bieber album, it's the album. You get the idea. And what I'm trying to do in this talk is to minimize the noise in our code in order to boost the signal. The signal being, what are we doing? And not worrying so much about the how. So first section, looking at how to eliminate noise on the absolutely microscopic level. This is the individual code level. So this is a big old block of code. What does it do? Can we tell in approximately 5 seconds? Chances are not, because there's an awful lot of noise here. What this is trying to do is really simple, but the noise is getting in the way of us working out instantly what the hell it does. So this is actually just trying to parse out some app settings into the appropriate types, checking whether they're valid, and if they're not, then we're assigning a default value. That's not terribly complicated, and mostly they're doing the exact same thing again and again, but we've got a whole load of extra gubbins around it to just do what should be a really simple task. So in any of these cases, if we wanted to add in a new app setting, we're actually having to add about 5 or 6 lines of code, which is a whole load for something that shouldn't take all that much effort. So what you can do is just pop in a couple of extension methods. And what these guys are doing, these attach to strings because your app settings come in as a string. And the second parameter is the default value. And based on the default value, I'm deciding which function to pass to, whether to do an int try parse or not, and to return either the incoming string, the this, the whatever the actual setting is, and if it's empty, null, not an integer, whatever, we'll give out the default value. All wrapped up in one. And that means that our code from before, which would have taken 5 to 6 lines of code to enhance, now looks like this. So to add an extra app setting, we add 1 line of code. Easy peasy. And it's really easy to tell what's going on. It's really easy to see what lines up with what. If there was a problem, it probably wouldn't take a lot of effort to work it out. So this for me is an awful lot better than what we had before. We've boiled down that big block of code into displaying just the essentials. We could probably go a step or two further if we were really bothered, but that's frankly good enough for me. So speaking of extension methods get a little bit of a bad reputation here and there. I've known places with strong opinions about not using extension methods. So I've come up with a series of commandments of extension methods to determine whether or not they're worth having or not. And when I say commandments, as is usual in the IT business. Andy and Sylvia says the number of people who get confused by extension methods is beyond belief. I will absolutely second that. But when I say commandments, as is always, it depends what you're trying to do. It depends on the constraints that you are under. It depends on politics within your company. Who knows? But generally speaking, these are my loose guidelines for developing extension methods and keeping them useful and not ruining your project. First and most important to me, know business logic. Business logic is what you're actually trying to accomplish. Business logic should be right at the front, screaming out to everybody what it is and how it works. That's the most important part of your code base. An extension method is the equivalent of taking that slightly embarrassing snarf action figure that you've had since the 1980s and popping it in a box somewhere where no one needs to know it exists, but you've still got it, and the off chance that you want to sit down and play Thundercats again. But you get the idea. Business extension methods are a way of taking embarrassing, annoying, tedious bits of code and stuffing them in a box where no one needs to look at them. So by putting business logic in an extension method, you are in effect hiding business logic, which is one of the very worst things you can do in your application. Keep them compact. If I can, I generally don't go even necessarily beyond a single line of code in an extension method. There are occasionally reasons why I do, but for me, a perfect extension method is about a line or so long. Keep them generic. Make the types involved as generic as possible to increase the amount that you can reuse them. Use T generics if you can. Sometimes you can't because that's the point of them, but I would keep them as generic as is humanly possible. Keep them portable. That meaning, for me, a good extension method is one I can take from my project and then drop it into any project in the entire world, and it would be fine and useful. And use them wherever there is boring, repetitive code. You're using them as a way of taking away the strain of writing the same old 3 lines of code that you're writing all over the place forever, and making your life slightly easier and making your code a little more friendly to look at. And make them useful. I was giving this exact talk early in the year, and someone told me they had worked at a company that created an extension method called isTrue. And I suppose that's a little bit more readable, but that seems a little overkill to me, to be honest. So a couple other examples of the sorts of things I might do with extensions. So this is a sort of generic parser. It will take any CSV string from a file, split it based on whatever the line should be split on, which will typically be a new line, and then split on that each line based on whatever separates the fields, which might well be a comma or whatever, and then returns an array of arrays. So that's a whole load of code that you may never have to write again if you're doing a whole load of parsing of CSVs into other data. It's taking out the repetitive element of that code and letting you concentrate on the more interesting aspects of the parsing process. You could simplify some of your null checks. I've now created extension methods that will check empties and nulls and stuff like that. That might possibly be a step too far for some, but consider that our code base is going to exist for a very long time, probably well beyond the end of your career in many cases. And there will be a wide variety of people looking at it. And they will be of an extremely wide variety of skill levels with C#. So sometimes it may be beneficial to switch out some of the slightly esoteric syntax of C# and replace it with something friendly and verbose. I'm not saying we'll necessarily always want to do this. Personally, I quite like the double speech mark, but it's a thing you can do if you want to make your code a little bit more reasonable. This is we have to understand not our hobby code that we're writing for our own sake where we can just code however we like. This is commercial code for a business, and so the aim of the game is to make this as maintainable and easy as possible. And something that I'll get onto again in a bit One of my favorite features of C# is dictionaries. I love dictionaries, but dictionaries have got a few problems that just out of the box stop them from being entirely useful to me. And one of them is the two dictionary syntax, where you have to do two separate lambda expressions in order to select out the key and the value from whatever the object is. And I don't like that. That's a little bit more verbose, and I'm really bothered about writing, especially when that's a key value pair. It's surely pretty obvious. So we can just extension method all of that nonsense away. So now I've got some extensions that will easily convert between a key value pair, or in the top case, that's a tuple, and just automatically convert them into dictionaries without us needing to write our same two lambdas every time. This is all small stuff. This is individual line stuff, but it's still just very slightly relieves some of the everyday tedium of writing out blocks of code. That's something I do sometimes when I'm writing reports, group by an object and then put them into a dictionary with the count as the item. So then we've got an easy report that we can make based on those objects. So that's line level. Let's move up a step and try and eliminate some code structure from our system. Okay, this is something that I used to talk about an awful lot when I worked for an American production company. And that's converting between Fahrenheit and centigrade, because like all British people, I talk about the weather an awful lot. And this is the formula for converting between centigrade and Fahrenheit. And it's multi-step. Each step depends on the one before it. We do one transformation, we multiply by 9, we take that new value, we divide it by 5. And there's a couple of things here that annoy me. For one, we've had to create these natty little temporary variables. I've just not even bothered to call them, give them names, but even that is getting in the way of just looking at what the code does. The A, the B, and the C there have no intrinsic meaning. They're not used beyond 2 lines of code, the one where it's defined and the next. And consider this also. This is a deliberately extremely simple example, but I have seen similar processes used in functions that were over thousands of lines long. And the A there at the beginning is still in scope at the end. So if your function is thousands of lines long and you've created an object right at the top, which is a complex object, that is still in scope and in memory all the way through that entire function. So with spinning up variables we don't really need beyond a single use to throw and then throw away, we're doing an awful lot of noise with this var this and blah blah, which we don't really need. So how can we simplify this lot? There. This is the neatest little extension method that honestly I never knew that I needed. And now whenever I start up a new project, I generally try and get this guy in. And this is map. So map attaches to a generic, which means it attaches to everything in the entirety of C#. And the single parameter it takes beyond that is a func, which converts whatever we are at the moment into something else. So if this is a string, it takes a func that converts that string into another string, an int, whatever. And that is literally all it does. But it means I can rewrite my last function like this. So consider first that now I don't even need the curly braces around the thing. I can convert the whole thing into an arrow function. So that's a little bit of noise removed already. Plus, I don't have those temporary variables. I'm just calling map, and then I'm passing into each one a lambda expression, which tells it how to transform from whatever we were into whatever the next step is, and then map again and map again. So those temporary variables aren't there anymore. Someone says second map is wrong. Oh my God, yes.
Times 9 divided by 9.
You're right. You win. Well done, you. Andy Pook. The amazing, fabulous no prize is making its way to you as we speak. I salute you, sir. Right. But glaring error aside, the principle still stands. Because that is a total load of useless code right there. Anyway, but the point is that the x that multiplies by 9 there that is only referred to within that lambda. And then by the time that that lambda is executed and we've moved on to the next step, which is inexplicably to then divide by 9, the original x is out of scope, and so thus subject to garbage collection. So not only is this neater, also it's potentially more memory efficient, because we're not holding on to anything for a second longer than we need it. So if we started writing our apps this way, we're possibly making our lives an awful lot easier. Suman Kumar says, cool example, thank you. Right. Now, one complaint I often get when I'm when I'm implementing this sort of method is about logging. Well, that's a fair point. So let me introduce you to the T. I don't know why they call this thing T. I really don't. But this is, I've also seen it called a tap. I've seen it called a few things. But the principle is, this is like a map, except we are taking this, whatever this is, and we're doing a thing with it, but then we're returning this again completely unaltered. So there we go. You can stick a T in the middle of our slightly bananas conversion there, and we can log it. Yes, someone's pointed out to the Unix T command. Probably. I don't know why they call it T. I really don't. But there we go. We're logging right in the middle of this structure. That could be go write it to console. That could be go stick it in a log file. Who knows? But the point is, though, we can break the process, interact with the object we've got at this point, and then move on unmodified. Oh, JC says it's T-pipe from plumbing. Could well be. Could well be. That might explain it. So this, incidentally, is one of the very simplest forms of a functional programming structure called a monad. I'm not going to dwell too much further on any of that stuff. I have another talk on the subject for those interested. So here's another sort of, oh, Dan says he's seen tap used in JS. So have I. I've seen him similarly called T, tap and T. I've seen them both in JS, but yes, absolutely. So this is another sort of a scenario that ends up typically involving an awful lot of code noise. So I got myself a little local function here called prepend hello, and it does exactly that because, well, why not? I'm friendly. I'm a nice guy. And I am going to do 2 get persons. The first appears to be summoning the devil. The second is that the neighbor of the devil, possibly. But the 6, now in my imaginary scenario, 666 returns an individual, and 616 does not. It returns null. So then I'm going to take those person objects, and I'm going to take person1 and person2.name, and I'm going to feed them into prepend hello. But of course, prepend hello 1 being passed into prepend hello to become hello 1, that's fine. There is an object. I promise you there's an object at the other end of that one. But for person 2, that's null. So trying to person 2.name will result in a big old code explosion. And that means that we've got to now rewrite our rather lovely concise code into something like this. So we're having to define hello1 initially as default. We're going to check against null person1, and if person1, and so on. And the code can get absolutely littered with this stuff. I've seen tons of functions out there where they're probably 3 times longer than really they need to be, purely because of stuff like null checks and how to respond after every null and stuff like that. Or you could do something along these lines. So this is a function called do if not null. It attaches again to a generic, which is everything, and it takes a func. This is kind of like our map from before, which converts old thing to new thing, and it's just a quick func. Now, the next line, the equality comparer, looks scary, but it is in fact just the generic version of a null check. You can't check against null with a generic because not everything defaults to null. Integers don't, booleans don't. There's a few other things that don't. But that's all that is. So it picks up whatever the appropriate default equality checker is and uses it. So what I'm saying is, if whatever the thing you just gave me wasn't null, then I'm going to take the function and I'm going to stuff this into the function and then pull out the new guy and pass it back to you. Otherwise, I am going to return a default value. So that's what that looks like if we put it back into our code. So size-wise, number of lines-wise, this is roughly the same as the original line of code, the original code sample, without all the null checking. But the null checking is still here. We've wrapped it into a little generic called do if not null. So what I'm doing is passing a lambda expression, which is in effect a little bit of code which I'm allowing the deeper code base to decide whether to execute or not. And I'm just telling it what I'd like it to do if it thinks it's a good idea. So if person one is null, then the lambda within do if not null will not be executed. And so we won't get a null exception error. Easy peasy. Took me ages to explain, but to be honest, it's fairly easy to read. So moving back on to dictionaries. I love dictionaries, like I said. So this is a dictionary containing theoretically every doctor from Doctor Who. Oh, someone's just mentioned options and maybes. This is another functional programming concept, and absolutely yes, and I have another talk on that sort of subject. I just thought it was a little out of scope for today. But yes, if for anyone interested in taking these concepts deeper, go and have a look into the maybe structure in functional programming. It's fabulous, but not doing it today.
Simon, I think we recorded when you came to .NET Oxford in person and did your functional C#. You went into it there, and I think we recorded it if I remember correctly. So I'll share the link if we did.
I'm not sure if you. Well, I'm not sure if it is recorded. I think you may have started like the week after I came or something.
Oh, maybe.
I don't know, but there's plenty of copies. I know for a fact that there is a recorded version of it from .NET Sheffield. So my talk is out there, and I'm available to do parties, bar mitzvahs, and all the rest of it. Kids' parties are absolutely not the same unless you've got me there talking functional programming. The look on the kids' faces is undescribable. So, moving on to my dictionary. So yeah, I've stopped short at poor old Peter Davison. Yes, I know there's a whole load of other doctors and the numbering gets complicated after number 8, but let's move on. The point is that I want to pass in an integer and get back a doctor. Now this, in the real world, is going to be a massively more complex example of something. I've kept it light and simple because I want to focus on the structure. And dictionaries give us this lovely syntax where we can just say doctor lookup, put an integer in there, bang, get an item out. That is so lovely and concise, and that's what I love about dictionaries. Awful lot of stuff you can do with them too. So this is fine. I can get Doctor 1 and get back the boss, William Hartnell. But if I put in 100, now this is one of the most mind-bogglingly strange things that I've encountered in C#. You put in 100, which doesn't exist within my, not yet, within my array, my dictionary, and it explodes. It will throw an exception. I have never understood why they chose to go that route, but fine, that's the way it works. So for me, dictionaries aren't really very useful unless we get rid of that behavior. And it is definitely something we can do. This is how I did it. So I am converting the dictionary into a lookup function. So note first, there are 2 arrows in each of those functions. There are 2 arrows. That means this is a func returning a func. Yeah. So the second one references the original dictionary. So here's our original dictionary right here. This iDictionary, thing to thing, this. So because this, can everyone see my mouse, by the way? Whee.
Yes, we can.
Yes.
Wonderful. Okay, good. I'm not just sort of ranting to myself. Right. So while this is the actual return value here, and for as long as this exists, held in a variable somewhere in the outside world, that keeps the dictionary in scope too. So that means that our original dictionary does exist, but we're not referencing it directly anymore. We're referencing it through the lens of this func. And this func is saying, check that the dictionary contains a key, whatever your key is. That'll be your integer in the case of my original example. And someone says, when are we going to talk about rest, or we carry on func? REST. I wasn't planning on talking about REST particularly. This is more sort of in these lines. Okay. Okay. The next door. There we go. Right. So if the key is contained here, then we return it. Otherwise, the default value. So in a couple of lines of code, we've now fixed the explode if the value is not found problem. We can now return. We just define the dictionary here, call toLookup with default, give it a default, and then this means that if we give it our 100, it will check the key within the extension method, and it will return the default value. So for me at least, that makes dictionaries a whole heap more useful than they used to be. I don't have to put all that sort of code bump around it to check against whether the value exists or not. And we can go further with this. We can take this a whole load further. So let's imagine now that we're creating an array. Someone says similar to try get. Similar, I'm just trying to put it in a form that's a little easier and friendlier to look at. So I'm going to create an array arbitrarily of the first, third, and fifth Doctor because I don't know. But anyway, the point is I'm creating an array. And I'm having to call that same function 3 times and do 3 lookups. And we've got a whole load of extra stuff that we need to do here. This create new array and the curly braces and so on. But there are better ways of doing this. So for a start, we could do this. So indexes. Indexes have been there forever. I'm surprised how little they're used, but there we go. They have their uses. It's allowing us to be a little bit more concise in our syntax, but that's a first step. So an indexer, I'm guessing everyone's vaguely familiar with them, but it's just a little function here which just says, give me the whatever the indexer is here, the integer in our case, and then call the dictionary lookup and throw that back at you. So that's a little better, but we can do a little bit better still. Because did you know, and I did not until fairly recently, but did you know that an indexer can take params? Because it can. So what that means is I'll say params int array within my indexer definition, and then I'll just call select on this so that each item in this gets the get doctor function called against it. And that means out in the real world here, we just literally say the lookup per application, give it 135 like this in a params, and that will automatically stitch that into an array for us. So I've got rid of all of the new array syntax. I've got rid of the 3 separate calls, and I've simplified it down into less than half a line. Like I said, I really love dictionaries. So, moving on, something that I'm not sure why I need to keep talking about, but nevertheless, I see an awful lot of people doing this. So, we've got a function here, which is got an awful lot of code bump in it, but fine. We're not concentrating on that at the moment. But it's getting a whole load of data, it's summarizing it, it's grouping it, it's transmitting off the report that we assemble from that lot, or sending a message to say there was no data, and we've got to try catch. We've got a whole load of stuff going on here. So because we're good folks, we will put some unit testing around this. So we'll unit test first that everything works. Good. We'll unit test that there was no data. Good. We'll unit test an exception. Great. So we're feeling pretty good now. If you were really good, you might have written the tests first, but nevertheless, still, we've got our testing. We're good. So then, like a scene out of Jurassic Park, you look down at your coffee and notice that it's going and rippling as something large and heavy and not terribly clever approaches. It's your boss. And your boss wants you to create a new report. Now we're going to look at property 2. Well, great. We can do that fairly easily. Yay! Created. I've done it. I am a genius. That was pretty easy, wasn't it? But here's a problem. What's the level of unit test coverage of this report? It's 0. there is no unit test coverage on this report. Even though we copied and pasted this guy from another report function which had 100% coverage, in effect, there is none here. So, and this approach doesn't scale up well. I mean, yes, we can duplicate our tests, but then what about when we want to do prop 3, prop 4, prop 5, prop 99? And then, and this is a situation I've actually encountered. What if someone, when they were creating prop 2, introduced a fault into the code, and every single prop instance since then, all the way up to prop 99, all replicated that same error from prop 2 all the way down? I have literally seen this in production, and it is truly painful. So why bother doing that? It does seem like the lazy, easy approach at the time, but actually, in the long term, it's adding to your workload. So the answer for me is to create, I don't know what the proper term is, but I'm calling it a donut function. So there we go. We'll just convert our prop1 function into a private. Take a func, which converts the sum data, whatever that is, into an integer. And then replace that with just our selector. So instead of selecting prop1 specifically, I'm selecting whichever integer value we're interested in. And then I can create each item out there and just reference the private and fill in the blank. In effect, I'm using the func as a blank inside our private function, which can be filled in by the outside world. This is in keeping with our open-close principle, if we're up on our solid principles. And if it were me, I might even go a whole load further than this, and I might even consider exposing the func as a parameter to the generic generate average report at the bottom there, and just turn that public. Just let whoever wants to call a report of whatever they're interested in, just using a func to decide what that is. Otherwise, we could end up with 99 items in our interface, which is also a problem in and of itself, and the sort of thing I've seen also in some workplaces. So that's our selector, right? And then other places I've used this sort of approach. I am not a huge fan of EF, but once in a while I have to use it. And one of the many problems with EF is you've got to be a little careful in how you instantiate your data store, whatever that your data set, and you'll probably have to call toArray at the end, because if you try and reference your query outside of your data, your iQueryable, outside of this using, you might find that it tries to go and hungrily slurp up some extra data from the database, but the database has been disposed of. So there's an awful lot of stuff you have to do every single time, and we could just expose a func, which is an iQueryable to an iQueryable, and you could probably put a generic in here if we did a little bit of creative thinking. And then within that, we will stick in our table, and we could even do stuff like this, where maybe there are certain records which are never supposed to be exposed under normal circumstances to the outside world. This is the top secret data. So we can now, within this function, ensure that anyone using this approach has automatically got the filtering done. We call our toArray, we've got our try catch. That's a really bad idea, but again, this is just a bit of dumb simple code. So you get the idea. We can just expose the EF query in such a way that we give the full range of EF query capability to the outside world, but we, within this function, are taking care of all the extra bits of code noise that we normally have to do around an EF query. So, other ways to use funcs, because there's an awful lot of uses for funcs if you get creative with them. This is something to validate usernames, and we've got a whole load of rules here. So we can't be null or white space. It's got to be less than 2. Got to be greater than. Oh, sorry. Can't be less than 2. Can't be greater than 20. Cannot be Justin Bieber, because that is wrong. And we've got a whole load of return falses, and at the end we've got to return true. So that's a lot of repeated structure and stuff that we don't necessarily need to live with. This is another little helper function that I tend to put in most of my projects. and it attaches again to a generic. It takes a params, because params is great for saving a lot of code noise as well. And it takes a params of funcs, which convert t, whatever t is, into a bool. That is this thing good or not? Then calls .all out a link. And all that expression does is just say, pass the original starting value into each function in turn. And since it's an all, that means that all must return true. If a single one returns false, then we exit the loop early and return false. So we can convert that entire function I had before into kind of technically one line of code, although one really, really long line of code that's unreadable without new lines, but still one line. Adding in an extra rule would be easy here. And also, it stops anyone from trying to make this thing get too complicated. Because I've seen an awful lot of places where you've got ifs, which then get further ifs inside them, which get further ifs inside them. You get these gigantic structures forming that look like family trees. And this is a way of keeping people honest and stopping the function from getting out of control in terms of what it does. This is another way you could do of applying the same idea I had before with my maps, where we're taking the value and then transforming it and then passing it on to the next. And you could just do an aggregate. Aggregate's another one of those little bits of link that not so many people seem to know about for some reason, but it's just a way of saying, take this list of stuff and slowly convert it one item at a time from a whole load of different things into just one thing. It's just, and inside here you are taking the ACK is the current value, X is the current value and ACK is the running total. And you just, whatever happens here becomes the new running total. So this has the exact same effect as my maps before, except you can't convert between types. You can also use, another way you can use dictionaries, because dictionaries are cool. You can use a dictionary to instantiate objects without needing an awful lot of this extra bit of bits and pieces, if you were doing a constructor where there are many possible return types. You can have a type of as the key to a dictionary, which can return out a func, which actually does that thing. So dictionaries have a lot of uses beyond the simple quick lookup of a bit of data. You can have funcs coming out of them and all sorts. So moving on to ways to be lazy with enumerables, because enumerables are cool too. So an enumerable is not data. An enumerable is not an array. An enumerable is just a pointer pointing at data. Until you actually enumerate, there's no data there to be had necessarily. It's wherever it is. In my example, there actually is. So I've got an enumerable which is pointing at an array somewhere else in memory. An enumerable has a couple of features. It's got what is the current item, and it's got move to the next item. Those features are available to you, but they're mostly hidden. But they exist. But what if my enumerable was pointing at something which was actually a great big long list of funcs, all of which returned complex objects? That means each move through this enumerable is a potentially expensive operation, and one we want to avoid for as long as possible, because it might turn out that for logical reasons we simply don't need this thing later, and enumerating the whole thing into memory was a massively wasteful idea. So can we keep an enumerable? Can we modify it, but without actually iterating through it? We can, because normally if you want to modify an item in an enumerable, you'd have to do something like this. You've got your original array, which has been have as enumerable pointing out. We want to replace the third item with the Z. So normally you'd have to iterate through this whole lot, effectively creating a second array, which is a copy of the first, and we will pop our Z in and then return out another enumerable. So we've just duplicated something in order to replace one item, which is feels a bit wasteful. So this is one possible way of fixing that problem. So this, I call it adjust, and call it as you wish. But what I'm saying is it attaches to all enumerables of all types. I'm giving out a func for the user to fill in, which is given the current item in the array, should either this position within the array, as in 0 for the first, 1 for the second position, so on and so forth, or should this some property of this item indicate that this should be replaced. So if this function returns true, we should replace it, and that's what we replace it with. And then we'll just do a select. Calling should replace for each and every item in turn. Now, because it's a select, it's returning an enumerable, which, like the original enumerable, does not actually contain any data until we enumerate. So if we use it like this, in my case, I am saying that here I'm saying if it's the item in position 2, which is this one, replace it with a Z. Here I'm saying if it is equal to C, then replace it with a Z. Now, this is a ridiculous example, and you probably never do this in the real world. But again, imagine that this is a complex object. That's the sort of place I'm trying to save some effort with. What it means is I've got an original enumerator and then a call to adjust, and each adjust is sitting like a filter between the original enumerator and the data. And then when you actually try to enumerate, it will say, go get me the current item, which will hit this guy, and it will do the check to see whether this is valid or not. If we've called adjust twice, then there'll be another guy. And for each call to adjust, it sits between the enumerator and the source data, and then decides whether to stick its foot down and replace the data with the new guy, or whether to just let this go on unchanged. In my super simple example, this is probably a very bad idea. But again, if we are actually dealing with large complex code objects, this might well save you a whole load of effort. Another situation that might cause you to need to enumerate the enumerable is if you want to compare consecutive values. So this is a function which arbitrarily checks to see whether there are any consecutive values inside our array. Spoiler, there is. And normally you would need to, well, this is an array, but if this were an enumerable, you would need to enumerate it out and then do a check with like I and I+1 or something like that. Or you could do it like this. So with this guy, I'm attaching again to any enumerable, and I'm doing funct, so that's the current item, the previous item. Are they consecutive? This is logic supplied by the outside world. So I'm getting the enumerator. So the enumerator is the engine that runs underneath the surface of the enumerable. This is the engine that drives the process forward. And if you crack this open, that means that you can have your own custom behavior through the system. Oh, Anonymous has asked, how is this affecting performance? That's not something I know a great deal about. I've heard that the difference, it's certainly not faster. I have heard tell that it can be either roughly the same or sometimes a little slower, but more often than not in my case, my concern is less about the speed of the system and more about making this thing easy to read in most cases. So if efficiency is what you're wanting, then probably you need to be looking at things like the spans and so on that come out of the high performance C#. But right, but anyway, we are getting our enumerator, and then there's another extension method I created, another any, which is attaching to an enumerator, and I'm just passing the func in here. And there, this is it. So we've got our enumerator. So that's our engine that drives the enumeration, and our func. So I'm saying move next. Move next is a property of enumerator, and this moves from position -1, which is where an enumerable starts, to position 0, that being the first item in the array. And it returns true if it returns true if there was an item to be found, or false if there was no item, as in we've gone past the end. So now I'm calling my map to say convert that into something else, and I'm saying, in fact, that X isn't really relevant. I'm just calling it to be concise because I like concision. And I'm calling that again. So we've moved to the first position. So I'm passing the enumerator in. I'm passing the func in so that we've still got it. And I'm passing this dot current. Now, this dot current is the first item out of the array, the one at I = 0, the first position item. So we've pulled it out and we're passing it in. So here's where I do the magic trick. Okay, so we've got our enumerator again, we've got our func again, and now we have here captured the first item out of the array, the item in position I = 0. That's right there. So we'll then move next here, and if that returned true, that being there was another item, then we'll run the function we'll pass in the prev here, the previous item that we captured before, and we'll pass in the current item. If that returned true, then that means that there was a consecutive value, so we'll turn the whole thing true. Otherwise, we don't know yet, and we'll call this same function again recursively, only this time the current this.current replaces the previous item. So we are juggling, in effect, passing the ball from one hand to the next, and then, ooh, I'm so sorry, got enthusiastic there. So like that. We're in each pass through this thing, we're holding on to the previous item and then passing it to the func again as to be processed against the next one. And also here we've got a false, which means we reach the end of the array and clearly nothing matched, so we'll return false. But all of this happened, in effect, without actually enumerating at all. So we can hold this whole thing in memory and only actually get a value out of it if we need to. Looks kind of like that. So it does y equal x plus 1. That is, x being the previous item. So if that previous item plus 1, I could possibly see some flaws in this. If the consecutive numbers are going the other way, this wouldn't work, and a few other things, but there, it's good enough. Last section. Attributes are a feature that I don't see used very often, but used correctly, they can be used to get rid of a whole load of code rubbish from the system. So I am parsing some hypothetical data here from Doctor Who stories. So this is parsing out some CSVs and turning this into data items in memory. So these are the details of the most recent series. And there we go, bit of parsing. The title's over here in position 1, the season is 11, the number of episodes is 1, the writer is in position 3, so there, easy peasy. But then we have a look at the data for series, whatever it was, the one before, so that's series 11, I think. And this time we notice that there is an extra field in place right here. And that is the episode number overall of the series ever since 1963. As well as the number of the episode within the season. So that pushes the title to a different position. So our previous parsing method won't work anymore. You could do something like this, where we're using our dictionary again, and we're using a dictionary with an enum to detect whether this is series 11 or season 12, and we're holding a func, and this func is something that will convert our array of strings into episode data. Well, that's not too bad. But I think we can do better still than that. That's how you'd call that. So that's using attributes. So attributes are those little things in the square brackets that you can attach to classes or to data properties containing either just simply text or even a parameter. And I've created one for the season number and the CSV position, which are the two things in our case that have shifted. So then I could create a structure that looks like this. So we've got our base episode data class, which are all virtuals, and it's an abstract, so we're not actually creating one of these, and it has to be inherited by each season with its own style of data. So the season number here is now set at 11, so that means I don't bother filling in the season number data because it's the same for every single episode in the whole of season 11, so why bother to set it myself? And the CSV position of title is different between these two. So I'm overriding title and telling it position 1 or position 2, depending on which season it is. That's the code for getting this sort of stuff. Now, this is a bit of reflection. So this may not necessarily be the most efficient way to interact with the code. So again, if efficiency is your overriding concern, this may not necessarily be for you. But you would use reflection to get the type of the data coming in. You get all its custom attributes, and then you'd select out the season number one, map that into a season number object, and then grab out the value. And we can wrap that into a more generic integer if we want, where we'll have to use a func, though, in this case, to select out what it is that we want over here. That is, this lot will just get out the attribute, and then the attribute may have one or more properties, and we have to use the func to select out which one we want. Ooh, and that's how you would go on to going even more complicated, trying to get the attributes out of a property that, oh, that is quite nasty to look at, not going to lie. But as I have said before, with extension methods, you write them once and then you throw them at the back of your code base and then you never think about them ever again. So yes, that's ugly, and it is. But you'll never look at that again, probably, because that basically just works. It's completely generic to within certain parameters. So you're unlikely to ever need to modify it, touch it, or anything, unless a better method comes in. Oh, okay. Right. And that's how I would call it. Now, again, this is a parser that will parse any episode data whatsoever, given that it's a descendant of episode data. This isn't entirely pretty either. We've got typeofs, we've got lambdas, but this is the only way that when we're actually maintaining this, when we're actually writing this thing, then this is all we need to do. When season 10 comes along, right here, and it's got a whole load of different CSV positions, then we just literally put a tag over the property, and those slightly ugly functions will run in the background, and they will sort out the magic of where the CSV data is within the structure. So we've saved ourselves a whole load of code mess just at the expense of writing a few ugly bits of code. Oh. You can even go a step further, and you can do things like have the line delimiter and the field delimiter as attributes, so that you never need to bother filling in that detail again. You could just attach it to the POCO itself. And that is the end of the talk. So I think we do need to hand over to Seb. Does anyone have any questions at this point, or do we need to be gone faster than that?
We can have a couple of questions. They're fairly quick. I guess I have one question. If I can start off the questions. Do you find that sometimes introducing things like map, func, t, and all this stuff into a C# code base really confuses C# developers that aren't from a functional background?
I've seen the people I've seen getting the most confused by it tend to be the folks who are the most. Someone's agreeing with you. Dong, nice. The people I've seen getting the most confused by this stuff tend to be the folks that are the most heavily invested in a background with object orientation. So the folks that have been doing object orientation for decades and more. The folks that I see getting the most getting to this stuff the quickest tend to be the folks that haven't been programming for anywhere near as long. So folks fresh out of university tend to have very little trouble picking a lot of this stuff up. So that's one thing. For another, I don't think it necessarily is all that difficult to understand. I think it's some people I know get nervous because they can't see how it works, as it were. They don't get the knowledge of the order operations is precisely this: go here, go here, go here, go here, go here. But I don't think there's any problem with just letting go of that and just going with clearly that's how it works and not worrying too much about it, because most of this stuff will spend the majority of its life in maintenance, and the majority of stuff you're going to want to do is just like throw an extra rule into that rule base. The business say there's now a 5th rule about passwords. Well, just throw one extra line in there, and even if you don't necessarily understand it, you could see pretty clearly how you modify it. Like just throw a quick func in that line, and there we go, job's a good one. So I don't think there's a problem myself. I can understand how some people would feel resistant, but I'll probably persevere. Does that answer your question?
Yes, it does. It's interesting because when I saw your first talk on functional programming a couple of years back, I hadn't done any functional programming at the time, and I remember that you're introducing things like option and all this different maps and stuff. And I remember thinking, I'll be very confused if I saw that in the code base. But afterwards, I read the functional C# book that you recommended at the thing.
Oh, is it Rico Buonanno?
Yes, that's the one. And then it started to click into place, and I started realizing that the stuff you were talking about isn't stuff you've invented. It's actual functional proper concepts. And I think that's where it clicked, and it started. that's where it started clicking into place for me, I think.
Yeah, I mean, this talk wasn't only about functional programming. Of course, functional programming is a really top-notch way of reducing the size of your code base. But there's other stuff in it too. But yeah, absolutely. The absolute best way to get in to really understand functional programming, to be honest, is just sit down and do it. Just like sit there, implement it yourself, and then there's usually a light bulb moment, and then from then on, it actually is quite easy. Some of these bits and pieces I completely invented myself, like the way of modifying dictionary. That's just pure me, that is. But in a way, it's following some functional principles, even if it's not a literal, real functional structure. And yeah, options is another way of really getting away from ever having errors ever again. Someone said, it's cool but a bit overwhelming. I could do with one example a day so I have time to absorb more of what you've shown. Well, I think this is being recorded, so feel free. And honestly, the very best way of absorbing some of this stuff is to sit there with Visual Studio and write it yourself out. You know, actually use it a little bit. And then I don't think it'll feel all that difficult once you've done it yourself. So, any more before Mr. Seb takes over?
Well, I'm just going to put in the chat window a link to the book that we mentioned that I said I read after your last talk.
Dong says he or she loves me. That's really quite flattering. Would you rather use F#? Okay, that is a good question, and one I get every single flipping time. It's a good question, though. This is why it keeps coming up. No, I wouldn't. Not because I dislike F#. Honestly, I've never learned it. It looks pretty good. I've looked at it. It looks nice, but it's got a very different syntax to C#. The problem with moving over to F# is everyone in the whole entire team has to be happy to do F#. And I don't think we're there yet. I could see it happening one day. I think it might come one day. But for the moment, go to a conference, throw a rock, and you'll hit someone that knows C#. And the examples that I'm using are all mostly straight out of the box C# that will work all the way back to about .NET 4, C#4 or so, I think. So F# looks lovely, but being practical and living in the real world, I think modifying C# might be the better way for now. And Dan has put a link to that book, Functional C Programming C#. It's a wonderful book and one of the best programming books I've read in a very long time. I didn't write it. That's just me loving it.